Okay, so we've got a question 5. A function f of x is given by this thing over here, and determine the inverse of that function. Now, one way to get into this, which could be quite interesting, is that you rewrite this in the form f of x equals a over x minus p plus q, because then you can kind of just switch your asymptotes. But let's go through it algebraically. You'd still have to do algebra this way anyway. So let's do it like this and say, well, our original function, is y equals x minus 5 over x minus 1. Well, if we want to work out what the inverse is, it means what's x is y is x. It's a reflection about the line y equals x. So let's say that for our inverse, that's a great writing inverse, right? And I'm just putting a code, I'm not saying it's equal to this, x equals y minus 5 over y minus 1. Now we can just do some algebra until we have y as the subject of the formula. So fraction, maybe it makes sense to multiply both sides by y minus 1 so that we have no more fractions. So we have x, y minus 1 equals y minus 5. Now we want y to be the subject of the formula, which means we'll have to do some manipulations. So we've got y by itself on one side, which will probably involve some factorization. So if we multiply the x in, and we have y minus 5 and xy minus, not doing well here, minus y, and then x minus 5, and we factorize out a y, which leaves us with x minus 1 equals x minus 5. Now we can just divide both sides by x minus 1. Now I've just dived straight ahead because, I think you can see it enough from here. X minus 5 over x minus 1. Okay, which is interesting because, as you saw in the memo, that this is a self-inverse function. The function and its inverse are actually the same function, which is quite cool. Okay, so that's that. I don't know. Any more questions, just ask them.